So to find the angle between two vectors, what you guys can see is we're doing a couple things. First thing is we are applying the dot product. Okay? And if you guys want to do, a lot of times, sometimes I do work on the side. And for this one problem, I will show all of my steps. All right? So you guys can see kind of like the process here. So the first thing is applying the dot product. So actually, I'll just kind of do this up top. So u dot v is simply going to be 2 times -2 plus 3 times 5, which is equal to -4 plus 15, which is equal to 11. Right? So I mean, once you guys do the dot product plenty enough times, you guys will you'll get a little hand of it. Then we need to find the magnitude of u, which is again basically the square root of the first and the second components of my vector squared. So that's going to be 4 plus 9. And then I have the magnitude of v, which is basically going to be those two components squared, added up. So that's going to be 4 plus 25. I've done a lot of this work before, so that's why I'm kind of skipping some steps. All right, but if you have a question or you missed where I went, how I got to those, let me know. Yes? 3 squared. Remember, it's v1 squared plus v2 squared, just like it's over there, a squared plus b squared. So therefore, I obtain square root of 13. And here I obtain square root of 29. So now what I have is cosine of theta equals 11 divided by the square root of 13 times the square root of 29. So therefore, theta equals cosine inverse. And I'm just going to use my calculator on this one. Thank you. So on my calculator, again, students usually make errors with their calculator on this. So I'm just going to do 11 divided by, parentheses, Diana, of the square root of 13 times the square root of 29. And I'm just very, very careful with my parentheses. And I get 0.5665, and then I'll just do inverse cosine of that answer. And I get 55.5, and I will just round this one to the nearest degree. Just be 55 degrees. Yes, Alma.
For 11, is that 11 then